Hi everyone, I'm Huub Hildenbrand. Thanks for tuning into my channel, Huub Hildenbrand Guitar Academia. Today we have lesson 7 of 4-note structures, and this lesson 7 will be really devoted to take a very scientific look at these 43 4-note structures. So let's get right into the endless ocean of music. So before we start this lesson, please go down in the description below. There is a link to a PDF file which you should download and print out if you like, because we will just go through this PDF and I will not explain everything what's on there. So if you don't have it, I think you will miss a lot of stuff. Maybe you will not really understand the lesson. All right. So as I said, we take a very scientific look at these 43 4-note structures, and it's a bit like a painter, like an artist who has their different colors, and they have a color chart, and they can have like complementary colors and what colors you have to mix to get that color and so on. And some time ago, when I was really busy with these 4-note structures, really worked on it, on them, I had this idea that there are these 43 structures, and every structure is like a kind of a color, and by putting together these colors, you paint this musical picture, so to speak. And I also read this book, The Craft of Musical Composition, I think. I'm not really sure now, by Paul Hindemith, and he also had a very interesting and for me very inspiring approach to different harmonies, to sounds, to intervals, which was not so related in terms of functions and tonality, but more as these sounds by themselves. He analyzed this he analyzed these sounds by grade of dissonance, grade of more melodic intervals or more harmonic intervals, and so he could actually, with his system, he made a kind of an ordering of all these different possible sounds. And yeah, so I also got very inspired from that book, and so I tried to focus on these 4-note structures for quite some time, and I wanted to really understand them in a way. So there came a lot of theories and statistics out of this period, which a lot I found like completely theoretic and not useful. So we will not talk about that. But some are very interesting, and that's what we are talking today. So let's get out this page about where it's written histograms. What are histograms? That's actually quite interesting thing. When you have a chord with 4 different notes, in this chord you will find 6 different intervals. If you count them from bottom up, it's like 1, 2, 3, 4. Then you have the intervals between 1 and 2, 1, 3, 1, 4. So 3 intervals. Then from 2 to 3, and from 2 to 4, and from 3 to 4. So these are 6 intervals. And these 6 intervals will always be there in some inversion, or you put an octave in between these two notes of one interval, but they are always there if you play any kind of a drop form, close position, open position, double drop 2, drop 3, whatever. They are always there. And I analyzed all these different 4-note structures and reduced every interval to its smallest form. So for example, if you have a C major chord, for example, you have C, E, G, B, close position. Then you have an interval between C and B, which is a major seventh. But I consider this as a minor second, because B to C is a minor second, and this minor second actually stands for all these different variations of how you can space these two notes. So you can have a C going up to a B, it's a major 7. You can have a B going up to a C, then it's a minor second. But you can also have a B which is going more than an octave to B again, and then to C, then you have a minor 9th, for example. So you have all these different versions, but in its essence, it's a minor second. And when you do this so basically you can only go until an augmented fourth or diminished fifth, because if you go higher, that's already an inversion of a smaller interval. So if I have a minor second, for example, I don't go up to a major seventh because I have already the minor second, and I don't need a perfect fifth, because a perfect fifth is just an inversion of a perfect fourth. So I have just these 6 intervals here. I have a minor second, a major second, a minor third, a major third, a perfect fourth, an augmented fourth or diminished fifth. And now, as I said, we have these 6 intervals in one 4-part structure, and we reduce it to the smallest form of each interval, and then we can write here how often each of the smaller intervals are happening inside one structure. So you see, for example, in the first line, C with F, C major triad with an F added, that we find there just one half step, one whole step, one minor third, one major third, and 2 perfect fifths. And I think I'm suggesting to you that you figure this out yourself. Just take any 4-note structure, write out a voicing or play a voicing on the guitar, and then take all the possible distances between all the possible notes in this voicing, and then reduce every interval to the smallest, to the small interval form, to the smallest version. So major 6 becomes a minor third, for example. And then find it here on this page, and you will see that it will be the same. I mean, for example, let's take another one, maybe a more like 4-part fourths, for example. We have a 4-note chord which is going a perfect fourth, augmented fourth, perfect fourth. Then we see, okay, this has 2 minor seconds, no major second, no minor third, 1 major third, 2 perfect fourths, and 1 augmented fourth, for example. And this actually also equals or not equals, but it's a sort of a fingerprint of that sound, of that structure. It's in a way it shows the sound of the structure in a kind of an essence, so to speak. Okay, and some sounds really have some sounds have the same histogram. For example, you have C major with F sharp, triad plus 4. This structure has every interval once, and also at the same time you have a C minor with a D flat added, and this structure also have each of these 6 intervals once, and so you actually can say they share, in a way, they share the same grade of dissonance, or they are very close, you can say. I mean, it's very logic. I think you would also think that's very logic. If a chord has a minor second inside, this is a kind of a tension which another structure which doesn't have a minor second doesn't have, or like a tritone, for example. A tritone is really it's really a sound which is more sticks more out of a sticks more out in a chord, for example, and it's a huge difference if a structure has a tritone or if the structure doesn't have the tritone. So it's a different grade of dissonance. And also Paul Hindemith, actually, he made this separation. He also made a kind of a chart where you can see, okay, this chord, or this structure belongs more here, this has a tritone, and this structure belongs more here, it doesn't have a tritone. And then in this tritone group, you also have chords which has a tritone and a minor second, and you have chords which have a tritone and no minor second, and that way you can, in a way, you can construct a kind of a chart where you see, okay, this is common to these sounds, and this is unique in a way. But we don't have to go so much into depth with this. Just for example, one interesting thing, if you look at it, you will find that the sounds which doesn't have a minor second and also doesn't have an augmented fourth, you will find 5 different sounds here, and interestingly, these sounds, they all come from the major or minor pentatonic. And this is a kind of a sound which doesn't have a tritone and doesn't have minor seconds. So it's a kind of a this is a kind of a mood, it's a kind of a sound, and by checking this histogram, actually it's also you can see it. I mean, you can just check. Okay, a minor second has a lot of tension. I don't want it in the music I'm now composing or improvising, and I don't want to have also an augmented fourth. So I will end up with 5 different sounds which all come from the major or minor pentatonic. I think that's quite interesting. And also there are certain sounds which don't have a minor second and don't have a minor third, and also don't have a perfect fourth. So they all, of course, they will belong to the whole tone scale, for example. And the whole tone scale is also a kind of a sound, a kind of an atmosphere you're creating with this scale. Okay, I hope this is kind of clear here. And please leave your comments if you don't understand. And remember, this is advanced stuff here. So we are, I'm assuming that you already know a lot of things. But anyway, if you feel you want to know that you don't understand, maybe I don't explain it very clear, or maybe I missed something in my explanation, so it's very hard actually to really understand it. Please leave your comments, because I want to make sure that it's very clear to you. Okay, so we have these 2 pages. Then we have this statistics and overview page. Actually, this I think this will be clear to you if you just read it through. For me, the interesting thing is actually that a 4-note structure is already a third of the whole possible tonal material. So with 12 notes of our equal tempered system, we just have 4 notes are already a third. So that's quite a lot actually. Also, what I missed actually with the histograms is that you can also invert a structure, and by putting it upside down, like exactly the intervals, to turn it around, you reach in most cases you reach a different structure, but it has the same histogram. That's also something what you can try. So if you have a C major chord, for example, or a major chord, you have C, E, G, B, so you have a major third going up, a minor third going up, and again a major third going up. Okay, when you turn this around, of course, then you have still a major 7th chord. But let's have another one. Let's have a diminished minor 7 flat 5 chord, for example. You have C, E flat, G flat, B flat. So you have a minor third, another minor third, and then you have a major third. If you turn it around, you start with a major third, then a minor third, then a minor third. You have a dominant 7th chord. And a dominant 7th chord and a minor 7 flat 5 chord, for example, they are quite related. And sometimes you can also use a minor 7 flat 5 instead of a dominant 7th chord. Like you have a dominant 7th 9, for example, and you don't have the root, then you have actually a minor 7 flat 5 chord, for example. So they are really related, and of course they have this tritone inside, and they don't have any minor second, so they are really near, really, yeah. Okay. All right. Each 4-note structure contains 4 different 3-note structures. That's also something for later when we will cover the 3-note structures. Then we can also think about that, and we can say, okay, we have a C major 7th chord. There are actually 4 3-note structures possible, and we can practice them. But this is stuff for later. Also interesting, if we really practice our triads, our major, minor, augmented, diminished triads, like the traditional triads, stacked up like third tertian harmony, stacked up thirds. Then we already by adding just one note, we can actually already reach 21 of these 43. So like the half of these 43 4-note structures. So for example, if you have a C major chord, we can just add a B, and then we have a C major 7th chord, or we can add an F sharp, then we have a C with F sharp, or we can add an F, or whatever. I mean, there are a lot of we can add all the other notes, and then we already have a lot of 4-note structures there. So, it's actually very connected, and these triads will give you a very strong basis to proceed here. Okay, then there is a page or 2 pages where this one here, on the left side you have all the different 4-note structures, and then on the top line you have the different parent scales. What are parent scales? Parent scales are actually the main scale system, so to speak, where you can also make your modes out of it. For example, in the first line you have first column, I think. There you have major, and major also stands for, of course, Ionian, but also Dorian, Phrygian, Lydian, Mixolydian, Aeolian, Locrian. So this major scale is like a parent scale for all the modes, and this is one kind of a system, also one kind of a sound in a way, atmosphere. And then you have harmonic minor. Then you have melodic minor, you have harmonic major. These are these 7-note scales where you also have all these 7 modes. Then also you have whole tone, halftone, whole tone scale. You have the whole tone scale and the symmetric augmented scale. And why I picked these scales, this is also a system actually. I will also explain to you in a later lesson when we talk about scales and the construction of scales. And these 7 scales actually, these 7 parent scales, they have the same rules in common, and we will talk about that later. But the page is actually great for your reference when you, for example, when you have a certain chord, like you have A flat with D, for example, a major chord with an augmented fourth, then you can look it up here on the left side. You see, okay, it's of course transposed back to C. It equals transposed the C major chord with an F sharp with an augmented fourth. And then in this line, you see all the places where you can find this chord in the different scales. So you see there is a 4, and these Roman numerals, they all stand for scale degrees. So you see, okay, a major triad with an added perfect fourth, I can find on the 4th degree of the major scale. Or I see I can find it on the minor, on the flat 6th degree of the harmonic minor scale. I find it also on the 4th degree of a melodic minor scale, and I also find it at the 1st degree of the halftone whole tone scale. So that's a very quick reference. When you have a nice sound, you can check it. What kind of scales will fit? For example, there we have like 4 possibilities to have scales, and all these scales they are really working here on this page. These 7 parent scales. The system here with these numbers these are Roman numerals which are standing for scale degrees. So the system works like this. We have the major scale, and we just count all the scale degrees, 1, 2, 3, 4, 5, 6, 7. And these are all like major or perfect intervals in relation to 1. And then we, in this case here on this page, if we want to have scale degrees in between, like in between of a second and a third, we use the flat sign. So we can lower Roman numeral by a half step to, and this procedure will bring us all the other possibilities, of course. Okay, then you also have a lot of footnotes here. These footnotes, they give you alternate names for certain structures. Or like different spellings of notes. And also with this symmetrical scales, like halftone, whole tone, and the second mode, whole tone, halftone, and also whole tone scale and symmetric augmented, they of course they are repeating at least after after the third note. So whole tone scale, for example, it's symmetric, and every note is in a way the same. From every note you have the same structure, only whole tones. So you don't, if you see a whole tone scale and you see, for example, this C augmented with an augmented fourth, C plus with F sharp, you find on the first degree of the whole tone scale. Then of course you also find it on the second, third, fourth, fifth, and sixth degree. It's just the same, symmetric. And also with a symmetric augmented scale, if you're not really familiar with this, it's like an augmented second or a minor third, and then a half step. And again, a minor third and a half step, and a minor third. And then when we have another half step, we reach the octave. So that's actually an interesting scale. And of course, there you also have just the first and the second mode, you can say. So everything what happens on what four note structure you can come up with on the first degree, you will also come up on the third and on the fifth degree. And on the second degree will be the same as the fourth degree and the sixth degree of the scale. It just has 6 degrees. Okay, and here also, please let me know in the comments if there is something you don't understand. Maybe just a very particular question, just one symbol or one footnote here you don't understand. Let me know. I will explain it to you. The last page, we have, this is a kind of an explanation, so to speak, all 4-part fours of major, harmonic minor, harmonic major, and melodic minor. This is an explanation where these weird 4-part fours structures are coming from, where I took it, so to speak. The procedure was to take the main for like parent scales, major, melodic minor, melodic major, and harmonic minor, and really stack up fourths on every of the 7 degrees. And sometimes it's a perfect fourth, sometimes it's an augmented fourth, but sometimes it's also a diminished fourth. And you also see these alternate abbreviations in the middle of the page. Sometimes I mix them up. A P4 is the same as a 4. P means perfect, so a perfect fourth equals actually a 4. A TT is like a tritone, and a tritone equals the augmented fourth, the sharp 4. And like this diminished 4 or 0-4 is like diminished, and the other symbol I'm using frequently is flat 4. So this is also a fourth which is flattened by a half step. So that way we have a 4, perfect, and we have sharp 4, augmented, and we have a flat 4, diminished fourth. Okay, so we go back to this, to the thing above. When I I do this stacking up of fourths in all these 4 different parent scales on all degrees. I come up with that what's written there, all these kind of structures like perfect 4, perfect 4, perfect 4, perfect 4, perfect 4, tritone, perfect 4, tritone, perfect 4, and so on, also with this diminished fourths. Just at the end, you find one structure which is not coming from these 4 parent scales, but which is coming from halftone, whole tone scale. And I also use this. I include this in my in this basic compendium of 43 structures. And this is tritone, perfect 4, tritone. But all the structures before, so all the structures without this last one, they are all derived from these 4 parent scales. And the first 4 you already find in the major scale. Remember, in the major scale, there is one tritone, actually, one augmented fourth, for example, C major scale, C, D, E, F, G, A, B. You have F, B, that's a tritone. All the other notes are just perfect fourths apart, but there you have a tritone. And this tritone can be as a lowest interval, as a middle interval, and as the highest interval. So these are these 4 possibilities of quartal harmony in the major scale. Then the next ones, they are you will not find in the major scale. You can only find in harmonic major, harmonic minor, or melodic minor. And just the first 4 of them, you see perfect 4 tritone, diminished 4 tritone, diminished 4 tritone, diminished 4 tritone, perfect 4. Only them I actually bring into the group of 4-part fourths, because the other 4 that's written, these are in another family. They equal the characteristics of the other families much better. For example, this tritone perfect 4 diminished fourths. This is actually a C major triad or a major triad with an added minor second. So why call it tritone perfect 4 diminished 4? Why make it so complicated? If you play these 4 notes and it sounds just like there's a major triad and there's a flat 2. So I decided to bring this sound in another family because it belongs more there sound-wise. Maybe from the theory it's a bit different, but also this chord, of course, it's more natural in a way. And if you have like a harmonic minor scale, for example, and you have on the 5th mode, you will just find this major triad with a minor second, for example. It's very, very common. So these structures, these 4 structures, you will not find in the 4-part fourths, but they are actually also coming. I mean, one explanation of them is to derive them as quartal harmony of these harmonic major, minor, and melodic minor parent scales. So you have alternate. You can say you have alternate names. You can say, okay, a C7 chord, for example, a dominant 7th chord, C, E, G, B flat, equals actually in the structure a quartal harmony, perfect fourth, diminished fourth, and tritone, for example. So you have, in a way, you have 2 possible names. And of course, if you play a quartal harmony, if you sing these chords in a certain, like in melodic minor or harmonic minor, you will reach these chords. And there you will sing more in a quartal way. You sing more in fourths because you only want to play all these possible different voicings in fourths, and then suddenly one maybe is a C minor 7 flat 5 voicing. But you sing it differently, so it has another name. And you just should be aware of different names also. And so you can also take, of course, and that's what we also did with this 12 roots, actually, when we analyzed these each of these 4-note structures, that we took a look at it and analyzed it really from all the roots. So there already you have a lot of names which you can give a certain structure. Okay, and at the bottom of the page you find on the left side you find names which we use in our compendium in the first lesson page. Remember where we have all these structures written down, and then on the right side you have alternate names for them. So it's the same like as above. You have different ways how you derive these 4-note structures out of certain scales, and if you derive the structure, for example, the first one, we have a C diminished triad with an added second. This structure we find, for example, on the 6th degree of melodic minor. So if we have C melodic minor, we find on the 6th degree A diminished, and we have also a B in the scale. So we can build a diminished triad with an added major second, melodic minor. But also, if we take a look at the other name here, we don't call this C diminished with D. We call this what the right spelling in this case would be C D E flat G flat. But now we call it C D E flat F sharp. And why we are calling this in that way? Because this is the right spelling for tetrachord. A tetrachord, for example, which we find on the 5th degree of harmonic minor. If you have G harmonic minor, we find on the 4th degree of harmonic minor, If we have G harmonic minor and the 4th degree is C, the 5th is D, the 6th is E flat, and the 7th is F sharp. So we have two possibilities, two derivations, you can say, two paths we get to the same sound in a way, the same structure, but from this other structure is like tertian harmony, like C diminished with D. C diminished is C E flat G flat, and the other is a scale-wise structure, like a tetrachord. So it's C, D, E flat, F sharp. Every name is present, a kind of a C, a kind of a D, a kind of an E, and a kind of an F. So that's an alternate name. And these alternate names here, in this case, they are only written for these structures which have an alternate, which you also can think in an alternate way, which is at the same time very not like theoretic in a way, but very practical, very musical also. Because from theory wise, you can find a lot of names. You call an augmented, or you can call a perfect fifth. You can call a double diminished, a diminished sixth, for example, or this kind of a thing. And this for us this makes no sense, because we are musicians. We are not scientists, so we wanna have a practical knowledge, so to speak. So it might look very scientific here and very disconnected from music, but actually it's not. It's just an attempt to also grasp the other side of the coin, so to speak. You have the sound, and then you have some explanations. And when you understand the explanations, also the sounds may become more clear, or you get more of an overview, or you, as a composer, you know more, you have more, your tools are just are working in a way better, because if you want to have a certain kind of a sound, you know where to look for. Or you see a sound and then you think, oh, I can also call it very differently. I can see it very differently. For example, with enharmonic spellings, what we just did with G flat and F sharp, and then suddenly this sound will open a complete different door for another modulation or another idea. And so if we don't know this theory, maybe we would not get that idea. And but of course, also in this guitar academia, or this is my thinking, of course, that I want to have my theory very much connected with practicality. So no, I mean, you can go so deep into theory and really be a scientist, and when you really do that, you are not a musician anymore. You're a mathematician or something like that. But as a musician, we have to internalize also the theory in a way. So we can't. Maybe you can say we should not know too much unnecessary stuff, because this will just hinder us to do something. So it should be really connected with the musical world, with our musical world. Okay, I hope you understood all this stuff I was talking to you today. Again, please leave your comments if not, and I will maybe put another video out later, or I will maybe I'll write another PDF file which you can download. But please ask questions. I mean, it's like, this is the good thing here, you know, with this format. It's not a book, buy it and go home. It's really we can use it more in an interactive way here. Okay, I hope you liked this lesson, and please subscribe to my channel. There is a video online every Friday. And you can also donate. You can go to my website, guitar-academia.com. There you'll find a button where you can donate to support my work here on this Guitar Academia. So, thanks for watching. My name is Huub Hildenbrand.